All right, so 10-4 is the quadratic formula, which we're going to sing. Oh, no, not that. Solving. I don't want to hear that again. I told you that. Solving quadratic equations by using the quadratic formula. Now there's a difference between the quadratic formula and the quadratic equation, as some of you learned on your quiz, right? So here's the quadratic equation. Ax squared plus bx plus c, and we will let y equal 0 when we're solving that quadratic. In other words, finding when it crosses the x-axis. And here is your quadratic formula. X is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so you might want to write yourself a note that this is sum to up goes the weasel. I think that's how you spell weasel. I don't actually write weasel all that often. All right, so you do need to memorize this, and the way you're going to memorize it today is you are going to sing it to yourself over and over again as you write it down. Now, I'm not going to make you write this down each and every time, but I will insist that you write down the template, and as you're writing the template and filling it in, you're saying the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So by the time you hit me on Monday, you're going to go, I am so annoyed with you. Me. Because now you have that song running through your head. Are you ready? We're going to sing. I want you to sing as loud as possible, because Monday we're going to blast out Olson's class. If she can ruin the noise in our class or disturb our class, we're going to disturb her class for once during the year. Are you ready? Oh, yes, we are. Are you ready? If you don't sing with me, you're singing by yourself up front. All right, here we go. X is the opposite of b squared all over 2a. That was very good. I won't make you do it a second time. That was excellent.
We should do it again.
I wasn't singing.
It's like I'm singing. I'm not going up there.
Oh yeah, messed up.
All right. So, oh, by the way, I will give you a pop quiz any moment next week. Well, let me just tell you, I won't be here on Thursday and Friday, so it has to be Monday, Tuesday, Wednesday over the quadratic formula with no notes. I'll give you 30 seconds to write it down, and that's it. And it's either right or wrong. So you either get 5 points or 0 points. Even if you miss a sign, miss a square root, if you don't have this division bar all the way across, I'll mark it wrong. So I am extremely picky on the quadratic formula. So you need to learn it by Monday, because I will give you a pop quiz at any point. Okay, fair enough notice. All right, so here we go. Example 1. And the reason why you have to learn it is because you will not be given, I am probably the only algebra teacher that doesn't give it to you on your test, because you need to know it. You're welcome. All right, so there are 2 different methods that we could use. Actually, there's more than 2 methods, but we're going to look at 2 different methods. There's 4 methods that we could use. We're going to look at only 2 for solving the following quadratic. So you might be asked to use 2 methods to solve. The 2 methods that you should be using would be either the quadratic formula and completing the square, or the quadratic formula and factoring. I wouldn't probably choose graphing as one of my methods. So here's my equation. X squared minus 2x minus 35 is equal to 0. So here is method number 1. We're going to start off by using the quadratic formula. Now, sometimes the quadratic formula is more work than factoring, sometimes it's not. This actually happens to be an easy one to factor, and so if you're really comfortable with factoring, you would choose factoring over the quadratic formula. If you're not comfortable with factoring, you would choose the quadratic formula over factoring, so it depends on who you are and where your strengths lie. So we're going to start with x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's what you're saying to yourself every time you do a problem today. Did I write down the exact formula? No, yeah. But you're using substitution parentheses, right? Somewhere on your paper you might want to use the formula once, write it down once, somewhere on your paper so that you're actually visually looking at that formula and replacing what you need to where. So your brain doesn't have to do so much work. So let's talk about what is A, B, and C. Before I can use this, what's A? 1. What's B? -2. And what's C? -35. So in B, I'm going to put in a -2. If you don't use your substitution parentheses, a lot of time I get just a -2 here, not the opposite of -2. And so it'll mess up your sign. So be careful. And a -2 goes here also. Then this is A and this is A. So a 1 goes here and here. And then C is -35. So then all that's left is for you to do order of operations, plain and simple. What's the opposite of -2? 2. Plus or minus the square root of, don't drop off that radical like some of you did with the distance formula. -2 squared is 4. Count your negatives. How many negatives do you have? How many? I have 2. I have a negative here in front of the 4 and a negative here. 2 negatives make a positive, don't they? All you have to do is 4 times 35. What does that give you? 140. All divided by 2 times 1 is 2. Make sure that that division bar goes all the way across and not just under the radical. Then add your numbers underneath the radical. Don't you get 144? Is that a perfect square? Yes, so that's good. Divided by 2. What's the square root of 144? So, oops, no radical, right? Just 12. All divided by 2. Then you can either write it out or ask yourself, what's 2 plus 12? 14 divided by 2? 7. And then 2 minus 12. But it's a -10, right? What's -10 divided by 2? -5. So x is equal to 7 and -5. Do work down and not across. Sometimes, like here, you might want to start to work across, but for the most part, I want you working down. So that wasn't so bad, right? It's just long, yes? Well, that's why we're doing method 2. If you're given a choice as to what method you want to use, I would use either quadratic formula, factoring, or completing the square. Completing the square is a great method to use on this one as well because 2 is divisible by 2. If your middle term is even, completing the square is fairly simple, right? All you have to do is move the 35 to the right. And this coefficient needs to be 1. The minute this term is odd, I would never use completing the square because it becomes a bit hairy, right? So then I'd either revert to the quadratic formula or I'd factor if I could. This is easily factorable, isn't it? So then we're going to go to method 2. So all these methods that we've been learning, they get you to the same place. So we're going to do our t-chart. I'm going to rewrite x squared minus 2x minus 35 equals 0. So one thing I'm looking for when factoring is that one side is equal to 0, typically, right? This is not a perfect square trinomial. There is no greatest common factor, so I have to use factor sum with group and garbage. Can I skip the group and garbage? Why? The coefficient is 1, right? So use your t-chart. You're going to take the coefficient of 1 times -35. You get -35. That means we're taking the factors of 35 and subtracting them, right, to get what? Negative 2. What factors of 35 subtract? Give me 2. My 2 is negative, so the bigger of the 2 gets that negative. What does the 5 have to be? Positive. So because we're skipping the group and garbage, we can put the x squared as x and x, and then a plus 5 and a minus 7. Then what do you do? Set each one of these equal to 0, so what does x equal? Negative 5 here and positive 7 there. Do we get the same answers as using the quadratic formula? Now, Tristan's asking, can I just factor on this one? Yes, unless I say you have to use quadratic formula, because then that means that I'm testing your knowledge of that formula. I'm not necessarily testing your ability to find the answers or the roots. I'm testing your knowledge of that process. So there will be times I'll let you choose. Okay? All right, so let's look at another one. Before we look at another one, let's talk about this number b squared minus 4ac. This is a very special thing called the discriminant, and it's going to tell us how many roots we have. It's going to tell us whether we have no roots, 1 root, or 2 roots. So this underneath that radical is extremely important. So flip this, and this is a part that you're going to have to study. It's a study thing. So you might want to write at the top of this, study the following. The discriminant and in parentheses it determines the number of solutions to a quadratic. The discriminant, it determines the number of solutions to a quadratic is a full sentence. Okay, but I didn't, and I wrote it this way, which is why I put the parentheses in. When you become the teacher, you can write it how you want. All right, so first thing, if your discriminant, b squared minus 4ac, notice that I am not using the radical. The value of the discriminant, you do not take the square root of. So and that's huge because that's one of the biggest errors that you're going to make. If I ask you for the value of the discriminant, and let's say that the number underneath the radical is 16, and you give me an answer of 4, because you took the square root of 16, you're going to be kind of wrong. So don't take the square root of it. Just take b squared minus 4ac. So if b squared minus 4ac turns out to be greater than 0, what kind of numbers are greater than 0? So in parentheses, you'll put positive. You will always have 2 real roots. The reason why I use the word real roots is because you can have imaginary roots in Algebra 3-4, your second year of algebra. But for our purposes, you're not going to have imaginary or things that don't exist roots. They're going to be real or not. And so that means that your parabola crosses the x-axis in how many places? In 2 places. And that also means that if your vertex is below the x-axis, does your parabola open up or down? Vertex is below the x-axis, does your parabola open up or down in this situation? It'd have to open up, right, for it to cross the x-axis twice. So therefore, if your parabola opens down, where would your vertex be? Above or below the x-axis? Above. So you need to have that kind of visual thing in your brain. All right, well, what if b squared minus 4ac is less than 0? Meaning what kind of numbers? Negative. So the number underneath the radical is negative. Can you take the square root of a negative number? No. So that means that you will have no real roots. This happens when your parabola does not cross the x-axis? And I'm going to ask you these questions, by the way. I'll say to you, describe a parabola that has no real roots. And your answer would be, or one of your answers would be, the vertex is above the x-axis and what? No real roots. It opens up, right? If your vertex is above the x-axis and it opens up, it's not going to cross the x-axis. So what's your other scenario? Vertex is where? Not resting on the x-axis because that would give you one real root. So I'm talking about what's my other scenario for no real roots. So we already did vertex is above the x-axis and opens up. So vertex is below the x-axis and opens down. So you might have to give me a scenario for how either of these two could occur. So describe in general how that could occur, and what I've just done is describe that. So then the last situation, if b squared minus 4ac is not greater than 0 or less than 0, what could it be? Equal to 0. So if it's exactly equal to 0, remember the situations in your homework last night where you had plus or minus the square root of 0? What kind of answer did you get? Well, what's the square root of 0? 0. What happens to a number if you add 0 to it or subtract 0 to it? It stays the same. So didn't you end up with a double root? That's where you have one real root. And how does one real root occur? When the vertex, make sure you don't use the word it's, but make sure you say the vertex. Because the parabola, and you don't want to say the parabola, you want to say the vertex. By the way, this is a double root. So this happens when the vertex sits on the x-axis. All right, so watch your homework tonight that you don't do more than what is asked. Because look at the directions might say to you, determine the number of solutions. It doesn't say determine what the solutions are. It just might say determine the number of solutions. So I'm going to give you a couple of problems where you have to determine what it is you're trying to find out, the number of solutions or what the solution is. So example 2. Solve using, bless you, the quadratic formula. Are you given a choice here? No. So if I just said solve, you can use whatever method you want to. You can use factoring, you can use completing the square, you can use quadratic formula. But here I'm not giving you a choice. So you're going to solve the following. 15x squared minus 8x is equal to 4. So let's just stop and think here for a moment. Number 1, if I were to solve this by factoring, what would I have to do first? Move the 4 to the left and set one side equal to 0. Do you really want to factor something that has a bookend of 15 and negative 4? Because you have to multiply those together. Wouldn't that require group on garbage? So is that a fun factoring problem? No. Would you want to complete the square with this problem? Well, that's divisible by 2, but isn't that an issue? So do you see why it might be nice if we had some other way to solve than factoring or completing the square? So this is why the quadratic formula is derived. So go ahead and solve it. What are you going to have to do first? You do have to have one side equal to 0. So you're going to have to move the 4 to the left. I'm okay with you doing that in your head as long as you do it correctly. So first step, 15x squared minus 8x minus 4 equals 0. Then you need to physically list out A equals, B equals, and C equals. I want to see what those values are. You go ahead and do it on your own. See if you can run it through the formula. I'll do the work up here and you can kind of check as you go. Watch your signs. what I have listed is not the actual final answer, by the way. Number 1, can I add the 8 and the 4 together? No. You have to look at what I call the Superman triangle of numbers. Technically, in the numerator, I have 2 terms. Do these 2 terms have a greatest common factor? Yep, what is it?
Thank you.
What do they have in common? A 4. So technically, I could factor a 4 out in front. I have a 2 left here and a 1 here, right? And then that 4 could reduce with a 30. You cannot just reduce 2 of these. You have to look at all 3 of these numbers. You can't just reduce these 2 numbers or those 2 numbers. You have to look at all 3 of these numbers together as one. So you can avoid factoring out the numerator if you look at all 3 together. Do all 3 together have a greatest common factor?
Yeah.
What is it? Only 2. So we're going to divide 2 into each one of those. So 2 goes into 8 4 times, 2 goes into 4 twice, and 2 goes into 30 15 times. So your actual final answer for x is 4 plus or minus 2 square root of 19 all over 15. What is the value of your discriminant, by the way? It's 304. Is that a positive, negative number, or is it 0? It's positive. So how many roots should I have? 2. Is this 2 real roots? A radical is a real root. Okay? If you have a negative under the radical, that's when it's not a real root. So one of my answers is 4 plus 2 square root of 19, all divided by 15. The other answer is 4 minus 2 square root of 19, all divided by 15. So you do have 2 answers there. It just looks funny. So this is your final solution. All right, the last thing that we're going to do is you're going to use the determinant to find the number of solutions. Are you ready? Flip it. Katie, can you give Andy those papers I asked you to give him, or asked you to find? Andy, she's going to, because your gal's going to come to whisk you away here shortly. She's going to give you the sheets that you've missed in this chapter. All right, so example, is this 4? 3? 3. All right, so use the determinant. Which is just b squared, and there she is, minus 4ac, to find, oh, one more thing, and this is today's homework. All right, to find the number of solutions. Oh, determinant, sorry. I'm getting pre-calc messed up. That's what happens when I'm in a hurry. But look, I wrote determinant. All right, well, apparently my hand knew what my brain was doing. All right, so use the determinant to find b squared minus 4ac, this is your determinant. No square root to find the number of solutions. So part A, we've got 4x squared minus 2x plus 14 equals 0. And then part B, you've got x squared plus 24x plus 144 equals 0. So I want you to find b squared minus 4ac, determine is that positive, is it negative, is it 0? And based upon that, I want you to tell me whether you have 1 real root, 2 real roots, or no real roots. You're not actually finding the roots, just how many. So you've got 2 minutes. Yes? No, we're not finding the solutions, just the number of solutions. So there's a difference in the question I'm asking you. I'm not asking you to actually find them. There's no sense in going through all that work if you don't need to. Yeah. You could take out a GCF and it won't make a difference, but you don't have to. Well, actually I wouldn't, because if I ask you for the value of the discriminant and you've taken out the GCF, it's going to be off, so don't do that. Good question. I haven't had anybody ask that before. Stop with all the noise. What are you doing, TJ? You're not packing up, are you?
No.
We're not done with class. We have 3 minutes. It takes you 10 seconds to pack up, so unpack it and take your stuff out. You're not done learning. What value did you get on A, TJ?
What?
What value did you get for part A? You got what? Nope. What value did you get for the discriminant? Negative, should be 220. Because 4 times 4 is 16, 16 times 14 is 224, and it's negative because you have one set of negatives, right? So that's bigger, so if you add the opposite, don't you get negative 220? So it gives you how many real roots? None. When you run this one through, you get A is 1, B is 24, and C is 144. When you run it through, doesn't it go through the formula this way?
Yep.
What's 24 squared? 576, and guess what 4 times 144 is? And don't you get 0? That means you have one real root. Any questions?